welcome to this lecture. In this lecture we will continue our method of Cauchy method of characteristic to solve first order nonlinear PD, and if you recall in previous lecture we have discussed the theoretical idea of Cauchy method of characteristic and how this method will help us to find out the integral surface in as a totality of characteristic curves. So let us consider some examples so that we can understand the established theory. So for that let us consider one example. So here we need to find out the solution of the equation z equal to 1 by 2 p square plus q square plus p minus x into q minus y, and which passes through the x axis. Now here, so first with the given data we try to find out the initial curve. So since data is initial curve is that it is passes through x axis, so we can characterize the initial curve as say x naught equal to some s. Let us say s is a parameter by which we are characterizing the initial curve. So x naught equal to s, y naught equal to 0 and z naught equal to 0, that is the parameterization of the x axis. So it means that data is that integral surface which should pass through the x axis. So we parameterize the x axis by this. So x naught equal to s, y naught equal to 0 and z naught equal to 0. So that will give you the initial value of x naught, y naught, z naught. Now look at the initial value of p naught and q naught. So for that we use the relation that your initial data, initial curve will lie on the surface, that is it must satisfy the equation of the partial differential equation, that is here put the values of x naught, y naught, z naught. So z naught is 0, so this is 0 equal to 1 by 2 p naught is square plus q naught is square plus p naught minus x, x is s here, and q naught and y naught is simply 0. So we have one relation that 0 equal to 1 by 2 p naught is square plus q naught is square plus p naught minus s into q naught, and the one more relation that your dz by ds equal to p naught dx by ds plus q naught dy by ds. So dz by ds is 0, p naught you need to find out, p naught s you need to find out, dx by ds is 1 plus q naught dy by ds dy y is 0, so it is again 0. So this will give you that p naught equal to 0. So p naught s we are getting as 0. Now using this p naught equal to 0 you can find out the q naught from this equation, and the value of q naught you can say that 1 by 2 q naught square minus s into q naught equal to 0. Then if you solve this you can see that you are getting two values of q naught, that is q naught equal to 0 and q naught equal to 2s. Now we will consider these as two different cases. So let us say case 1, case 2. So initial strips are 2, let us write it in a case 1, case 2. So let us say in case 1 x naught equal to s, y naught equal to 0, z naught equal to 0. This is common in both the cases. The only thing is that p naught equal to 0 and q naught equal to 2s in this case, and another case your p naught equal to 0 and q naught equal to 0. So first in case 1 we try to find out the integral surface, and then we will in case 2 also we will find out the solution of integral surface. So here your characteristic equation of this PD is given by this following thing. So how you can obtain? So here if you look at your z is equal to what, 1 by 2 p square plus q square plus p minus x q minus y, right. So we can write your f of x y z p q equal to the whole you take the z this side and you can write 1 by 2 p square plus q square plus p minus x q minus y minus z, right. And then you look at what is your f of p. So f of p is basically you differentiate this, so we will get p, and here you will get q minus y, that is all. So this is f of p, and similarly f of q is what, if you look at here f q is again q plus here you will get p minus x, and p f p you can easily calculate. Now what is f of x? F of x is basically minus of q, so it is y minus q basically, and f of y is basically x minus p, and f of z is basically minus 1. So using this you can find out dx by dt as f of p, that is p plus q minus y. So let me write it here. Dy by dt is equal to fq, so fq plus p minus x we have written here. Dz by dt is pfp plus qfq, so pfp is this, fq is this, so we have written dz by dt. dp by dt is minus of f of x plus p of z. So f of x is x minus p and sorry, f of x is y minus q, and this p f z, that is this. So we can say that it is p plus q minus y. Is it okay? So that we have written, because minus sign is inside, you can make it inside. So dq by dt is your minus of f of y plus q f z here. Let me solve this. It is minus f of y is basically what, x minus p minus q, f z is again q. So this you can write it p plus q minus x. So dq by dt is also given. Now we need to solve these set of ordinary differential equation, and initial data is already obtained, like case 1, x naught equal to s, y naught equal to 0, z naught equal to 0, p naught equal to 0, q naught equal to 2s. So theoretically we can solve this ordinary differential equation and we should have a solution. But here now theoretically it is possible. Now your experience will come into picture, and we solve this depending on the equation to equation. So here you can easily see that if you look at this equation, this dx by dt equal to p plus q minus y and dp by dt equal to p plus q minus y. So we can write d by dt of x minus p equal to 0. Similarly you can look at this and this. So it means that d by dt of y minus q equal to 0, right. So here you can simply say that x minus p is constant with respect to t. Similarly y minus q is constant with respect to t. So we can write it that x minus p equal to c naught and y minus q equal to c1 say. Now we need to find out what is the value of c0 and c1. For that you can use the initial value. Now initial value is what, x0 equal to s, I am looking at the first case, y0 equal to 0, z0 equal to 0, p0 equal to 0 and q0 equal to 2s. So here you can use c0, this implies that c0 is equal to what, c0 is equal to sem, and c1 equal to what, c1 equal to minus 2s. Is it okay? c1 equal to minus 2s. So we can write our equation as x minus p equal to s and y minus q equal to minus 2s. That is what we have written here. This x minus p equal to s and y minus q equal to minus 2s. That is what we have written here. So x equal to s plus p, y equal to q minus 2s. But we cannot utilize this also, because the value of x, y is given in terms of p and q. So we have to handle, we have to find out the value of p and q. We cannot say that it is the solution here. So for that look at the your equations. So here you look at the value of p plus q minus x, and we can observe if we look at d by dt of p plus q minus x, then it is given as p plus q minus x. For that you look at dp by dt plus dq by dt minus dx by dt. So if you look at dp by dt is what, dp by dt is this thing, p plus q minus y. So it is p plus q minus y plus what is dq by dt, dq by dt is p plus q minus x, p plus q minus x minus what is dx by dt, it is same as p plus q minus y. So it is p plus q minus y. So you this will cancel out, you will have p plus q minus x. So here we simply say that d by dt of p plus q minus x equal to p plus q minus x, and we can say that p plus q minus x is e to power t. So here we will get that p plus q minus x equal to some constant, let us say c2 e to power t. Now I need to find out the c2, and again we will use the initial condition, that is 0 plus 2s minus s equal to c2. So at t equal to 0 your initial conditions are given as like this. So here you can say that c2 is s. So we can write p plus q minus x equal to s e to power t. Similarly, we can find out the value of p plus q minus y, and it is coming out to be 2s et. So, that also you can find out. Now, once we have this 1 relation, 2 relation, 3 and 4. Now, using 1, 2, 3, 4, we try to solve x, y, p and q. Here z is not involved, so we can have 4 relation and 4 unknown to find out. So, we can easily solve our x, y, z, x, y, p and q. So, using this you can solve as how we can solve. You just look at the value of p plus q here in both the things, and you can find out the value of p plus q here and just equate, and you will get x and y and p and q here. So, this I am leaving it to you, that verify that your x is equal to s into 2 e to power t minus 1, y equal to s e to power t minus 1, p as 2 s e to power t minus 1 and q as s e to power t plus 1. So far what we have obtained is, we obtained the parametric say 2 parameter family of in terms of x and y, but we have not get any expression for z also. So, we also want 2 parametric representation of z. So, for that we have to look at the equation dz by dt. So, here we have look at dz by dt equal to p f p plus q f q, right. So, using this you go back to this equation, then p plus q minus y you already know, p plus q minus x you know, p and q, all these are now known to us. Now, using this you can write dz by dt. So, let me write it, what is dz by dt. So, dz by dt is what? Dz by dt equal to p f p is p plus q minus x, right, p plus q minus y. So, p plus q minus y is 2 s e to power t plus q f q is s e to power t. Now, you write p also, p and q also in terms of this. So, p and 2 s e to power t minus 1 into 2 s e to power t plus q is what? S e to power t plus 1 into s e to power t. So, this is dz by dt. So, now it is totally in terms of s and t. S is constant with respect to t. So, you can solve this dz by dt. Now, this again I am leaving it to you to show that your z is coming by this 5 by 2 s square e to power 2 t minus 1 minus 3 s square e to power t minus 1. So, now we also have the 2 parameter representation of z. So, now x, y and z will define an integral surface, and now integral surface is given in terms of 2 parameter representation of surfaces. But if you want the relation which is not given in terms of 2 parameter value of 2 parametric representation, then we have to remove the parameter s and t, and when you remove the parameter s and t, so from these 2 equation you can find out the value of s and t in terms of x and y, and you can see that you can solve the first 2 equation for x and y, and you can get the value of E t and s like this, that E t is y minus x upon 2 y minus x, s as x minus 2 y. So, using the value of e to power t and s, you can now solve for z, and you can use the expression for this, s you know, e to power t you know, and you can put it here and you can simplify, and you can get your solution as z equal to 1 by 2 y into 4x minus 3y. So, that I am leaving it to you, that simplify and you can get this. Now, this is the case when we have assumed the value of q naught as 2 of s, but if we have another case also when q naught is equal to 0, then in this case we again solve this our set of ordinary differential equation, and we have x as s plus p and y equal to q. Now, once we have this, then again we can apply the same thing, that d by dt of p plus q minus y is equal to p plus q minus y, and we can get this value p plus q minus y equal to minus s e to power t and p plus q minus y equal to 0. So, these 2 equation we can obtain and from 1 dash 2 dash 3 dash 4 dash you can solve x, y, p and q, and we can get our solution like this, that p equal to 0, q equal to y, x equal to s, q equal to y equal to s minus s power et. So, we can write here s equal to x by solving this, and e to power t as x minus y upon x. When you simplify, then dz by dt equal to p into p plus q minus y, and if you look at p plus q minus y is coming out to be 0. So, this is 0 plus q p plus q minus x, that is written as minus s e to power minus s e to power t, and you can use the value of q, and then you can simplify dz by dt as y into y minus x, and we can simplify this as dz by dt equal to s square e to power 2t minus e to power t, and we can again integrate, and using the value that z not equal to 0, you can simplify that z equal to s square by 2 e to power 2t minus 2 e to power t plus 1, which is nothing but the whole square of e to power t minus 1. So, z equal to s square upon 2 e to power t minus 1 whole square. Now, we already know the value of s, that is s is equal to x, and you can simplify similarly you can find out the value of y as from the last equation, that is y equal to s minus s e to power t. So, we can get the value of e to power t from this. So, we can see that on eliminating s and t we get the following relation, that is z equal to x square by 2 x minus y upon x minus 1 whole square, and when you simplify it is nothing but y square by 2. So, you can say that z equal to y square by 2 is also an integral surface. So, now what you have obtained in this example, we have obtained two set of integral surfaces, right, and these two set of integral surfaces are obtained because your initial data is basically two initial data, that your integral curve passes through the x axis, right. So, here corresponding to two set of integral data, we have two integral surfaces. Okay. So, that is what we have obtained in this particular example. Now, let us consider one more example. In fact, we will consider two more example to get the correct thorough understanding of Cauchy method of characteristic. So, this example is using the method of characteristic, find the integral surface of PQ equal to xy, and which passes through the line z equal to x, y equal to 0. So, first thing is the get the parametric representation of initial curve. So, here how you can find out the parametric representation of z equal to x, y equal to 0. So, you use the parameter s to represent this. So, we simply say that x naught is equal to s. If x naught is s, then z naught is also s, y naught is 0, z naught is s. So, x naught, y naught, z naught is there. How to find out p naught, q naught? For that you use partial differential equation, that is pq equal to xy, and relation dz equal to p dx plus q dy. So, this is true for any parametric. So, dz by ds. So, dz by ds is basically 1 equal to p naught, you need to find out dx by ds is 1 plus q naught, dy by ds is 0. So, p naught is coming out to be 1. So, p naught is 1. Now, using this, since it is p naught is 1, q naught we need to find out, x naught is s, y naught is 0. So, q naught is coming out to be 0. So, here we have only one initial data, that is s 0, s 1 0. So, these are x naught, y naught, z naught, p naught, q naught. Now, initial data is given with us. Now, once we have initial data, now we look at the set of ordinary differential equation. So, we have, for that we simply say that pq minus xy we call as f of x y z p q equal to this, then f of p is equal to q, f of q equal to p, f of x equal to minus y, f of y equal to minus x, and f of z is equal to 0. So, once we have, then dx by dt equal to fp, so q, so dx by dt equal to q, dy by dt equal to fq, that is p here, dz by dt equal to pfp plus qfq, so that is pq plus pq, so it is 2pq, dp by dt is minus f of x plus p of fz, right. So, fz is 0, so it is f of x is minus y, so it is coming out to be y here, dq by dt is x. So here if you look at our equation is what, dx by dt equal to q, dy by dt equal to p, dz by dt equal to 2pq. So to solve our idea is to find out x, y, z in terms of s and t. So but here to solve x, y, z in s and t, we need to solve first for p and q, because your dx by dt is in terms of q and dy by dt in terms of p. So first we need to solve dp by dt and dq by dt. Now dp by dt is given in terms of y and dy by dt in terms of p. So you can use this and you can simply say that d2y by dt square is equal to dp by dt, that is y here. So from this you can solve your d2y by dt square is equal to y, and this is this has a very simple relation, and you can say that you can write your y as some linear combination of e to power t and e to power minus t. Similarly you can write down that d2x by dt square is equal to dq by dt, that is x here. So again for the same thing, d2x by dt square is equal to x, and you can write x as a linear combination of e to power t and e to power minus t. So we have written x equal to a e to power t plus b e to power minus t, and q is nothing but q is nothing but dx by dt. So dx by dt means q is written as differentiation of this with respect to t, that is a e to power t minus b e to power minus t. So that is q here. Similarly we can find out y, that is c e to power t plus d e to power minus t, and dp p as dy by dt, that is c e to power t minus d e to power minus t. So once we have p and q, right now it is in terms of c and d, a, b. So we can do one thing, that we can use initial data right now to find out a, b, c, d, or let us solve for dz by dt also. So dz by dt is 2pq, and you can find out the value of p and q, and you can write down this expression, and when we simplify you have this expression. Now our idea is to solve your a, b, c, d, because to solve a, b, c, d we need to use initial data, and initial data is what, x naught is equal to s, y naught equal to 0, z naught equal to s, p naught equal to, that we have to, p naught is equal to 1 and q naught equal to 0, right. So since x t s is given as so x t is given as what, a e to power t plus b e to power minus t. So here when we write x t s, it means that I am assuming that a and b are a function of s. So a s is basically what, this is value s equal to a s e to power t is simply 1 plus b s e to power minus t is again 1. So a plus b is equal to s, so that is this relation. Then using the relation for q, that is a s minus b s equal to q naught, that is 0 here. So a minus b equal to 0. So with this we can find out the value of a and b, that is a equal to b equal to s by 2. Similarly using the relation that y naught is equal to 0, we can write that c plus d is equal to 0, and p naught equal to 1, we can write c minus d is equal to 1. So c plus d equal to 0 and c minus d equal to 1, it means that c equal to minus d equal to half. So and we also know that the z naught is equal to s. So z naught is basically what, you can get this from that here ac minus bd minus 2 times bc plus no t is 0, so this will be gone, plus e. So we have ac minus bd plus e equal to s. We already have a, b, c, d, so we can find out the value of e, and that is given by e equal to s by 2. So what we have now is this, x equal to a to power t plus b to power minus t. A and b we already know, so it is nothing but s by 2 e to power t plus e to power minus t. So we can write this as s cos hyperbolic t. Similarly we can write y as c e to power t plus d e to power minus t. So it is what, 1 by 2 e to power t minus 1 by 2 e to power minus t, and we can write this as y equal to sin hyperbolic t. Now using this all values of z a, b, c, d, you can write down that z is coming out to be s cos hyperbolic square t. Either you solve using this, or you first with the help of x y you got the value of p and q, and with the help of p and q you can solve dz by dt equal to 2pq, and then you can get z equal to this value. So, it is up to you whether you directly put the value or you use the value of p and q to find out z, it is up to you. So, we can get your z as s cos hyperbolic s square t. Now, we need to find out the integral surface formula whose which is not given in terms of 2 parameter. So, you remove the 2 parameters s and t, and once we remove the parameter s and t, you can get our solution as z square equal to x square into 1 plus y square. So, from this if you look at from x equal to s cos hyperbolic t and y equal to sin hyperbolic t, you can get the value of s, right. And once we have s, and then you can put y as sin hyperbolic t. So, you can get the value of sin hyperbolic t, and you can simplify this. S is given as x by y and cot hyperbolic t. So, you can simplify this z square equal to x square into 1 plus y square. So, here we have solved this example also. So, now we will consider one more example, which I think by this we must have cleared our data, and we know what we try to do in each and every example. So, let us consider one more example. So, find the characteristics of the equation p q equal to z and determine the integral surface which passes through the parabola x equal to 0 y square equal to z. Now, what is the characteristic? Characteristic are the solution of integral solution of differential equations. So, those equations those solutions are known as characteristics. Now, let us do it is. So, first thing is parameterize your initial curve, that is x naught equal to 0, y naught equal to s, then z is automatically s square. Once you have x naught, y naught, z naught, use your PD, that is p q equal to z. So, p naught q naught equal to z naught, that is s square, and dz by ds equal to p dx by ds plus q dy by ds. So, here dz by ds is what? 2s equal to p naught dx by ds is 0 plus q naught dy by ds is 1. So, you can get q naught as 2s, and p naught you can get it from this. When we have q naught, you can find out the value of p naught, that is s by 2. So, we have p naught q naught. So, now we have all the initial values, x naught equal to 0, y naught equal to 0, s, z naught equal to s square, p naught equal to s by 2, q naught equal to 2s. Now, look at the differential equation. So, differential equations are dx by dt equal to all these things. So, for that you have equation p q equal to z. So, p q minus z equal to 0. So, that is your f of x, y, z, p, q. Now, here f of p is q, f of q equal to p, f of z equal to minus 1, f of x equal to 0, f of y equal to 0. So, dx by dt equal to fp, we got it q, dy by dt equal to q fq, that is p, dz by dt is equal to pfp plus qfq, then again to pq, dp by dt equal to p, and it is minus of f of x plus pfz. So, fx is 0. So, we will get a p, fz is minus 1. So, we will get p, dp by dt equal to p and dq by dt equal to q. Now, again look at here dx by dt, dy by dt, all these involve p and q. So, first we have to solve dp by dt and dq by dt. So, dp by dt here it is quite easy. So, here p is given as something constant c naught e to the power t, and q is also some c1 e to the power t. Now, how to fix this c naught? So, here at t equal to 0, we already know that p naught is equal to what? So, p naught is given as s by 2 and q naught is equal to 2s. So, we can write it here, the value of c naught is equal to s by 2 and value of c1 is equal to 2s. So, we can write p2 as s by 2 e to the power t and qt as 2s e to the power t. So, pt and qt is now known to us, then we can write it dx by dt equal to q is 2s e to the power t and dy by dt equal to what? dy by dt is equal to p, that is s by 2 e to the power t. So, when you solve this, what you will get, x of s of t is equal to 2s e to the power t plus some constant, let us say c3, and y of st will be what, s by 2 e to the power t plus some c4. Now, how to get c3? So, for that initial values is what, 0 and s. So, here it is 0 and here it is s. So, t equal to 0, it is 0 equal to 2s plus c3, and here t equal to 0, it is s. So, s equal to s by 2 plus c4. So, c3 and c4 is, c3 is minus 2s and c4 is equal to s by 2. So, s by 2. So, using c3 and c4, xst will be what, 2s e to the power t minus 2s. So, you get 2s e to the power t minus 1. So, we have x of st is equal to 2s e to the power t minus 1. Similarly, you can get your y of st. So, let us look at here. So, x of t is 2s e to the power t minus 1, yt is equal to s by 2 e to the power t plus 1. Similarly, once we have the value of p and q, which we have already obtained here, you can get dz by dt equal to 2pq, that is we can solve and you can get zt equal to s square e to the power t. So, this is the integral surface given in 2 parameter family. Now, to get remove this parameter, you can use simplify and you can get the x by y equal to what, 4 times e to the power t minus 1 divided by e to the power t plus 1, and from this you can get the value of Et, and you use the value of Et and you can use any of the relation, you can get your s here. So, here this is I am leaving it to you, that find out the value of e to the power t and s, and hence we can put it back to this equation, and you can write down your relation of z in terms of x and y as follows: z equal to 1 by 16 4y plus x whole square. So, this is the integral surface which we want to obtain. Now, please look at here, if you look at, if we solve only these equations, then we will get a solution in terms of constants. So, it means that the solution of this without utilizing the initial data is the equation of characteristics, but if you utilize the initial data, then it will be an integral strip rather than characteristic strip. So, integral strips means that will contain the initial curve, right. So, if you find out all these C1, C2, all the constant integration constant, then it will be an integral strips, and with the help of integral strips we have 2 parameter family of the solution, that is what is written here. So, this is an integral surface given in terms of 2 parameter family of representation. Now, this is equally fine, but many a times people want that we should have a equation of surface in terms of z equal to g of some function of x and y. For that we have to remove the parameter s and t, and that we can remove from this, and we have a integral surface after removing the parameter s and t. So, with this I end our lecture, and I hope that you have a better understanding of whatever theory we have already discussed in previous lecture. So, I hope that you will try to solve all the problem to get more insight of this. So, with this I end this lecture. Thank you very much for listening. Thank you.